look at the normal curve, okay, so if you look at the normal curve, what are the important things? If you look at the normal curve at the peak, it has only one peak. Because if you have more than one mode, then you will have, like if you have two modes, then you are going to have this kind of a curve, two modes. So normal curve has one mode, so it's unimodal, and mean, median, mode, all these three things, they fall at the same point, which is right at the middle of this curve. So this one right here, that's for mean, median, mode. That's a unique feature of normal curve. Second one, if you look at these two tails, see this is the axis, but these tails, they do not touch the axis. So it keeps on going. Another thing is, if you look at this normal curve and if you divide it into two halves, then this half is equal, exactly equal to the left half. So it's a symmetrical curve. In using this normal curve, what we actually do, what is the use for, or what is the purpose of using normal curve? By using normal curve, we try to look at the area under the normal curve. Since it's a symmetrical curve, the area covered under the normal curve this whole area under the normal curve equals to 1. Since it's a symmetrical curve, if you divide it right in the middle, then half of this normal curve area is 0.5. Similarly, this side, this half is also 0.5. And for those, we use this table. What we have in this table is the area under the normal curve. So given that situation, what is the use of this normal curve? The use is, if we are, first of all, what we try to do in statistics, we try to figure out the possibility of something happening. So how we can figure out that possibility? If you look at this handout, you can zoom in. If you look at this handout, right in the middle, you have this formula which says Z equal X minus mu divided by sigma. So for this formula and using this normal curve, we are using two parameters. One is the mu, which is the mean, because we talk about not the sample but the population. So that's why instead of, remember the sample mean X bar, so we don't use that. Since we are dealing with the population, we use mu. Since we are not dealing with the sample, we don't use this S for standard deviation. We use this, we use that sigma for population, standard deviation. So always remember that. So we use this formula. That means if we are telling you to find out the possibility of something happening, then that something which is going to happen, that will be your Z. So for that one you have to calculate the Z-score. Once you calculate the Z-score, then based on your Z-score, you look at this table. See what you have this table. Look at the first column. The very first column at the top it says Z, right? So 0.1, if your Z-score is 0.1, then the area under the normal curve is 0.0392. Are you guys with me? If your Z-score is 1.0, then first of all, when you look at this column, how many digits you have after the decimal point? 1 digit, right? So if your Z-score is 1.0, then you go down this line and then you look at the second column, which is 0.00. So that area under the normal curve for 1.0 is 0.3413. What if your Z-score is 1.25? Which column you are going to look at? You go down the first column, look for 1.2, okay? And then you go toward your right and look for the column which says 0.05. 0.05 plus 1.2, that's 1.25. And then you go down the line and then find out the area under the normal curve. So that's how we use this table. Now, talking about this thing is not going to do any good, so we need to do some calculation, right?